Hello and welcome back. So we were discussing first order differential equation and we discussed linear first order ODEs before, and if you remember, the standard form for linear first order ODE is dy over dx plus pxy equal to qx. This is the standard form. Now, to go ahead with this lecture, you will need the knowledge for the first order linear ODEs. If you don't remember, just brush up your knowledge once and come back. So in this lecture, we are going to talk about Bernoulli equations. And Bernoulli equations are of the form dy over dx plus px times y equal to qx y power n. So the difference between our linear first order ODE and this Bernoulli equation is this power n, y power n multiplied with qx. This is non-linear ODE because it involves y power n, if n is different from 1 obviously. So this is the form of Bernoulli equation. Now if n equal to 0, then Bernoulli equation is our linear first order ODE, and we know how to solve it. Okay, if n is equal to 1, then the term on the right hand side will be qx times y. Okay, let me show you. So it will be pxy equal to qxy. So if we subtract pxy both sides, we will get qx minus px times y, and we will divide by y both sides. So this is basically our separable equation, and we know how to solve separable equations. So for n equal to 0 and n equal to 1, we know how to deal with Bernoulli equations. Now we will look for the cases when n is not equal to 0 and not equal to 1. So now we are assuming n is not equal to 0 and not equal to 1. Now let's see the procedure. To solve the Bernoulli equation. I'm just rewriting it. Px times y equal to qx y power n. And this is the procedure when n is not equal to 0 and n is not equal to 1. Step 1. We substitute v equal to y power n minus 1. And this is the only thing you need to remember. That's all. Just remember this substitution and we will be fine. Just for completion, I'm writing down the other steps, and you will see for obvious reasons, you will need to multiply the equation, the Bernoulli equation, the given Bernoulli equation, by 1 minus n times y raised to power negative n. If you look at this clearly, this is nothing but derivative of v with respect to y. And after doing this, you will see that your equation reduces to first order linear equation. And now we know the game. What we need to do, how to solve first order linear equation. Let's see one example. Okay, before that, very important note. Once you solve the differential equation, never forget to plug in your v back. Your answer should be in terms of the variables you were given initially. So never forget to substitute v back. Let's see some example about the Bernoulli equation and things will be more clear then. So first example. So first example is, say, t square y prime plus 2ty minus y cube equal to 0, and we want to solve this ODE when t is greater than 0. Okay. When you are given this ODE for the first time, we will start analyzing the ODE, right? So first, let's start analyzing the ODE. First point, we see that this is first order ODE. Okay. Next, this is not linear. So this is not the case of first order linear ODE. Why this is not linear? Because this have a y cube term. So this is not linear. Next we will check if this is separable or not. To do that, let's divide this equation by the coefficient of y prime. So y prime is, we are dividing by t square, so we will get 2 over t y minus y cube divided by t square equal to 0. And for your separable equation, the form was dy over dx equal to a function of x times a function of y, a function of independent variable times a function of dependent variable. But here the y and x terms are mixed and we can't separate them as a product. To make it more clear, let me go one further step. So we have y cube divided by t square minus 2 over t times y. We can't separate it as gt times hy. So from here we can say, okay, this is not separable. Not separable. Then we analyze if this is Bernoulli or not. Okay, so our equation is here. So this is our equation. And it's clearly Bernoulli. We can write it as, this is first order, we have a y term, and everything we will put on the right hand side. So 1 over t square y cube. Okay. So this is Bernoulli equation. Very nice. The only thing we need to know is the substitution. We substitute v as y power, the dependent variable, power 1 minus n. N is, so here our n is power of dependent variable on the right hand side. It's 3. So 1 minus 3. So we will substitute v equal to y power negative 2. This is our first step. And in step 1, we will also calculate the derivative of v with respect to the dependent variable, which is with respect to the independent variable. So here, so our substitution is v equal to y power negative 2. The derivative of v is, we bring the power in front, we reduce the power by 1. So negative 2 times y raised to power negative 3. So here our substitution is v power negative 2, right? We will calculate the derivative of v. We bring the power in front, we reduce the power by 1 times, whenever you are taking the derivative of a dependent term, you multiply by the derivative of y with respect to t. So this is equal to negative 2 times y power negative 3 dy over dt. Right? Now see here. This is our original Bernoulli equation. And we want something in form of v. We want to convert this equation in form of v. We have a y prime, but our dv over dt, our v prime is equal to negative 2 times y raised to power negative 3 dy over dt. So what we will do is, we will multiply our original equation by negative 2 times y power negative 3. That's obvious, right? And we will get negative 2 times y power negative 3 y prime plus 2 divided by 3 times negative 2 y power negative 3 times y equals to negative 2 times y power negative 3 divided by t square times y cube. We are multiplying this equation by negative 2 times y power negative 3. Okay. Our first term here is v prime. So we will get v prime plus negative 2 times 2 is negative 4. So negative 4 divided by t y power negative 2. If base are same, we add the exponents. So negative 3 plus 1 is negative 2 equals to negative 2 divided by t square, because negative 3 plus 3 is 0. And our y power negative 2 is v. So this equation is basically y prime minus 4 over t times v equal to negative 2 divided by t square, which is, and this is first order linear ODE, which we already know how to solve. We will calculate the integrating factor, which is e power coefficient of v negative 4 over t. Okay, this integrating factor is in terms of the independent variable, which is t here, dt. So we got e power negative 4 integration of t is natural log of t, which is equal to e power natural log of t power negative 4. Here we are using the property ln of a power b is equal to b times ln of a. If we have something in multiplication, it goes to the power. So this negative 4 was in multiplication, so it will be ln of t power negative 4. Now exponential and natural log are inverse of each other, so our integrating factor is t power negative 4. Once we get the integrating factor, we multiply our linear ODE by the integrating factor. So we will multiply integrating factor v prime times 4 times t negative 2 divided by 2 square t power negative 4. And if you have calculated your integrating factor correctly, your left hand side will reduce to derivative of integrating factor times the dependent variable. Let's check if we have calculated our integrating factor correctly. So the derivative of t power negative 4 times v, we'll use the product rule to calculate that. We keep t power negative 4 as it is times derivative of v, plus we keep v as it is and derivative of t power negative 4 is we bring the power in front, which is negative 4 times t power negative 3. So this is correct. And this is equal to negative 2 t power negative 6. Now we will integrate both sides with respect to x. Again, our independent variable is t, not x. So we will integrate both sides with respect to t. We integrate both sides with respect to t. So integration and derivative are opposite of each other. So in the left hand side we will get t power negative 4 v equals negative 2, which is a constant, so we can pull it out. We increase the power by 1, so negative 6 plus 1 is negative 5 divided by negative 5 plus a constant of integration. We divide both sides by t power 4. So we divide both sides by t power negative 4, or we can say we are multiplying by t power 4. C times t power 4. So we will get v is equal to negative will cancel out, 5t plus c times t power 4. Now this answer is in terms of v, and we want our answer in terms of y and t. So we will substitute v back, and value of v is y power negative 2. So y power negative 2 equals to 5t plus c times t power 4. And this is our final answer. 1 over y square is equal to 2 times 40 divided by c. Your final answer should always be in terms of the variables which are given to you in the initial problem. Thank you, and I'll see you in the next video.